The sky is bleeding light. One by one, the stars you have known your entire life are simply blinking out, not because they have run out of fuel and not because of cosmic dust. The very fabric of reality is tearing apart, and there is nowhere left to run. This is not a slow cooling or a quiet fade. This is the Big Rip, the most violent, absolute, and terrifying end allowed by the laws of physics. If these cosmic mysteries resonate with you, please subscribe to the channel for more deep dives into the unknown. Now we begin our journey into the final hours of everything. Look at the images captured by the James Webb Space Telescope, peering into the deepest reaches of the Perseus Cluster, or the Pillars of Creation. Every shimmering point of light represents a home to trillions of worlds, held together by the invisible glue of gravity. But these photographs, the most detailed records in human history, hide a dark, growing secret. The spaces between these galaxies are stretching. The void is winning. What we once thought was a stable, eternal stage for the dance of the stars is actually a ticking time bomb, and the fuse has already been lit. For centuries, we believed the universe was a static, unchanging cathedral. Even Albert Einstein, the man who decoded the laws of gravity, could not accept the idea of a universe that moved. In 1917, when he formulated his equations of general relativity, he found a disturbing truth. His math suggested that the universe must either be expanding or contracting. It could not simply sit still. To fix what he thought was a mistake, he added a mathematical bandage called the cosmological constant, represented by the Greek letter lambda. It was an invisible energy meant to push back against gravity just enough to keep the stars in place. He later called this the greatest blunder of his life. But as we are now discovering, Einstein's blunder might actually be the most accurate description of our doom. The illusion of a static universe shattered in 1929 at the Mount Wilson Observatory. Edwin Hubble, peering through the 100-inch Hooker telescope, noticed something strange about the light coming from distant galaxies. The light was shifted toward the red end of the spectrum. This phenomenon, known as redshift, meant that these galaxies were moving away from us at incredible speeds. Hubble's law, expressed as velocity equals the Hubble constant times distance, changed everything. We learned that we live in a dynamic, growing cosmos. For decades, the big question was not if the expansion would stop, but how fast gravity would eventually pull everything back together in a big crunch. We thought we were living in a universe that would eventually come home. We were wrong. In 1998, two independent teams of astronomers set out to measure the slowing of the universe. They looked at Type 1a supernovae, dying stars that explode with such consistent brightness they are known as standard candles. By measuring how faint these explosions appeared, they could calculate exactly how far away they were and how fast they were receding. They expected to see the expansion breaking, slowed down by the collective weight of all the matter in existence. Instead, they found the impossible. The expansion was not slowing down, it was accelerating. It was as if every galaxy in the universe had stepped on the gas pedal. This discovery, which earned the Nobel Prize, introduced the world to the most mysterious force in nature, dark energy. Dark energy is not like anything we have ever touched or measured in a lab. It makes up roughly 70% of everything that exists, yet we cannot see it, feel it, or block it. It is the energy of empty space itself. As the universe expands and creates more space, there is more dark energy, which causes even more expansion. It is a self-reinforcing cycle of cosmic growth. To understand the Big Rip, we have to look at the equation of state for this energy, defined by the parameter W. If W is exactly -1, then dark energy is a constant pressure, and the universe will expand forever but stay intact. But if W is less than -1, we enter the realm of phantom energy. This is where the nightmare begins. Phantom energy is a theoretical form of dark energy that becomes more dense as the universe expands. Usually when things get bigger, they get thinner, but phantom energy defies this logic. As the volume of the universe increases, the strength of the push becomes more violent. It begins to overpower every other force in nature. First, it overcomes gravity on the largest scales, then on the scale of galaxies, then stars, then planets, and finally, the very bonds that hold your atoms together. It is a runaway process that leads to a mathematical singularity where the expansion rate becomes infinite in a finite amount of time. The clock is ticking toward a moment when the distance between any 2 points in space becomes infinite, effectively shredding the map of reality. The reason physicists are panicking today is a phenomenon called the Hubble tension. For years, we thought we had a handle on how fast the universe was growing. We measured the cosmic microwave background, the afterglow of the Big Bang, and it gave us one number. But when we look at modern stars and galaxies with the Hubble Space Telescope and the James Webb, we get a different number. These two measurements do not agree, and the gap between them is growing. This is not a simple rounding error. It suggests that our fundamental model of the universe is missing something massive. Some scientists believe this tension is the first sign that dark energy is not a constant, but a dynamic, evolving force. If it is getting stronger, the Big Rip is not just a theory, it is a prediction. Recent data from the Dark Energy Spectroscopic Instrument, or DESI, which has mapped over 30 million galaxies, has added fuel to this fire. In 2024, researchers announced that they found hints that dark energy might be changing over time. If the density of this energy is increasing, we are on a one-way track to the rip. We are beginning to see the universe not as a stable balloon being inflated, but as a piece of fabric being pulled from all sides by invisible, vengeful hands. The James Webb Telescope has also found massive, mature galaxies in the very early universe where they should not exist. This challenges our timeline of how gravity works and suggests that the push and pull of the cosmos is far more aggressive than we ever dared to imagine. Imagine a future, billions of years from now, where the laws of physics begin to fail. It starts in the great voids between the superclusters of galaxies. These are the largest structures in the cosmos, webs of dark matter stretching across hundreds of millions of light years. Under the influence of phantom energy, the gravitational ties that bind these clusters begin to snap. The Great Attractor, a mysterious gravity anomaly that has been pulling our local group for eons, loses its grip. One by one, the distant lights of the universe slip past the cosmic horizon. They are moving away from us faster than light, meaning their image can never reach us again. The universe is becoming a series of isolated islands, each destined for total darkness. As the phantom energy density continues to climb, the destruction moves inward. Our own local group of galaxies, including the massive Andromeda and our Milky Way, were supposed to collide and merge into a giant elliptical galaxy dubbed Milkomeda. But in the Big Rip scenario, this union never happens. The space between our galaxies begins to swell so rapidly that even the light-speed journey between us and our nearest neighbor becomes impossible. We are left alone in the dark. Then, the Milky Way itself begins to feel the strain. The dark matter halo that stabilizes our galaxy is stripped away. The majestic spiral arms, home to hundreds of billions of suns, begin to unravel like a ball of yarn. Stars are flung out into the intergalactic abyss, orphaned and drifting. We often think of the vacuum of space as nothingness, but to a physicist, the vacuum is a roiling sea of potential. It is filled with virtual particles popping in and out of existence. Dark energy is a property of this vacuum. If the Big Rip is our destiny, it means that the cost of space is getting higher. Every cubic centimeter of the void is gaining the power to destroy. This is the ultimate irony of our existence. The very thing that allowed the universe to grow and form stars is the same thing that will eventually act as its executioner. We are floating on a sea of energy that is slowly turning into a storm. The terror of the Big Rip lies in its scale. In other end-of-the-universe scenarios like the Big Freeze, life might find a way to survive for trillions of years around small, dim stars. But the Rip is democratic in its destruction. It does not matter how much energy you have or how advanced your civilization becomes. You cannot hide from the expansion of space, because space is everywhere. It is inside your ship, inside your home, and inside your body. There is no shield that can stop the vacuum from expanding. When the threshold is crossed, the phantom energy becomes stronger than the electromagnetic force. This is the force that holds the electrons in orbit around the nuclei of your atoms. When that happens, the very concept of matter ceases to exist. We have to ask ourselves why we are seeing these signs now. Is it possible that the universe has gone through cycles like this before? Some theories of cyclic cosmology suggest that a Big Rip could be the trigger for a new Big Bang. As space is torn apart and the energy density reaches a peak, the resulting singularity might undergo a quantum bounce, resetting the clock and starting a new expansion. But for us in this cycle, the conclusion is final. Every memory, every monument, and every atom of our history will be scattered so far apart that they can never interact again. The universe will not just be dead, it will be erased. In the 19th century, we worried about the heat death, a slow, cold exhaustion of energy. But the 20th and 21st centuries have revealed a universe that is far more temperamental. We have discovered that the vacuum is not a cold, empty void, but a pressurized reservoir of power. The fact that the expansion is accelerating is the most important observation in the history of science. It tells us that gravity is a weak player in a game dominated by the energy of the void. We are living in a brief window of cosmic history, a few billion years where the stars are close enough to see and the Earth is solid enough to stand on. This window is closing. The math of Robert Caldwell, the physicist who first championed the Big Rip, suggests a timeline that is terrifyingly short in cosmic terms. If the parameter W is even slightly less than -1, the end could come in as little as 22 billion years. That sounds like a long time, but considering the Earth is already 4.5 billion years old, we are already well into the second act of this play. The universe spent the first few billion years slowing down, allowing galaxies to form. But about 5 or 6 billion years ago, dark energy took the lead. We are now living in the era of the Great Acceleration. Everything we see is a temporary arrangement, a brief moment of order before the phantom energy reaches its breaking point. To understand the scale of this force, we have to look at the vacuum energy catastrophe. When physicists try to calculate the density of the vacuum using quantum mechanics, they get a number that is 10 to the power of 120 times larger than what we actually observe. This is the largest discrepancy between theory and observation in all of science. It means we don't truly understand the ground we are standing on. If even a fraction of that hidden quantum energy begins to manifest as phantom energy, the Big Rip wouldn't just be inevitable, it would be instantaneous. We are essentially balanced on a needle's point, hoping the vacuum stays stable just long enough for us to exist. As we look deeper into the Hubble tension, we find that the mystery only deepens. Some suggest that there is a dark fluid that changes its properties as the universe ages. Others think that gravity itself might behave differently across vast distances. But the most haunting possibility is that we are witnessing the beginning of a phase transition. Just as water turns to steam when it reaches a certain temperature, the universe might be shifting into a new state, where the expansion is no longer controlled. If this transition is underway, the ripping might already be happening in the most distant reaches of the cosmos, far beyond our current horizon, moving toward us at the speed of light. To understand why the Big Rip is the most terrifying end of all, we have to look at the cosmological constant problem, which many physicists call the worst prediction in the history of science. When we use the rules of quantum mechanics to calculate how much energy should be in empty space, we get a number that is 10 to the power of 120 times larger than what we actually see. If that full amount of energy were actually pushing the universe, the cosmos would have ripped itself apart in the first trillionth of a second after the Big Bang. Galaxies would never have formed, atoms would never have stayed together. The fact that we exist at all means that something is cancelling out almost all of that vacuum energy. But if the balance shifts even by a fraction of a percent as the universe ages, that latent, monstrous power begins to leak out. This is the essence of the phantom energy. It is the sleeping giant of physics, and it is starting to wake up. We are currently living in the lambda CDM era, which is the standard model of cosmology. In this model, dark energy is a constant, unchanging background, but the Hubble tension we discussed earlier is like a crack in the hull of a ship. It tells us that the standard model might be wrong. If the expansion rate is actually higher than our formulas predict, it means the push is increasing. Scientists are now looking at quintessence models, where dark energy is a dynamic field that can change its strength. If this field evolves into phantom energy, the universe's expansion will eventually become a runaway train. The further we go into the future, the more work the vacuum does to tear things apart. It is a cosmic tax that gets more expensive every second, and eventually the universe will no longer be able to pay the price of its own existence. Let's look at the great dissolution of our cosmic neighborhood with even more detail. Imagine the year 20 billion. The Milky Way has already become an isolated ghost. The stars that once made up the beautiful Orion Arm are now drifting apart. In a normal universe, gravity would keep these stars in orbit for trillions of years. Но в сценарии Великого Разрыва само пространство внутри галактики начинает расширяться. It's not that the stars are moving through space, it's that the space between the stars is growing. Think of it like a rubber sheet with coins glued to it. If you stretch the sheet fast enough, the glue, gravity, will eventually fail. The stars are the coins, and the vacuum is the sheet. By the time we are 60 million years from the end, the Milky Way is no longer a disk. It is a scattered cloud of lonely suns. each one receding from the others so fast that their light can no longer reach their neighbors. If there were any civilizations left on those planets, their night sky would be a total oppressive black. As we move toward the final months, the focus shifts to the solar system. This is where the physics of the rip becomes truly visceral. Gravity is a weak force. It's easy to overcome. You do it every time you jump. But on the scale of a solar system, gravity is the law. For billions of years, the sun's massive weight has dictated the paths of the planets. But as the density of phantom energy continues to climb, the pressure of the vacuum begins to rival the sun's pull. At 3 months before the end, the outer planets, Neptune, Uranus, and the gas giants Saturn and Jupiter are the first to go. They are simply carried away into the dark. They don't fly off because of a collision. They are simply unhooked from the sun's influence. Their orbits stretch, become unstable, and then vanish. The sun, once the master of its domain, is left alone, its family of worlds stolen by the very void they inhabited. Now, let's zoom in on the Earth. Within the last hour of time, the phantom energy becomes stronger than the gravity holding our planet together. This is a moment of total geological madness. The Earth's core, a ball of molten iron and nickel, begins to expand. The crust, the rocky shell we live on, cannot handle the internal pressure. Massive fissures, miles wide, open up across every continent. These aren't like volcanic eruptions or earthquakes. They are the result of the planet literally swelling from the inside out. The atmosphere is the first thing to be lost, as the air molecules are pushed away into space. The oceans follow, boiling into the vacuum as the pressure drops to zero. Finally, the planet shatters. It isn't an explosion of fire, but a mechanical failure of reality. The rocks, the mountains, and the remains of our cities are turned into a fine dust that is immediately accelerated away at millions of miles per hour. But the most haunting part of the Big Rip is what happens to you. Biology is based on chemistry, and chemistry is based on the electromagnetic force. This force is what keeps electrons bound to the nuclei of atoms, and what keeps those atoms bonded into molecules like water or DNA. About 1 minute before the end, the phantom energy becomes stronger than electromagnetism. This means that every chemical bond in your body and every object around you fails simultaneously. Your cells don't just die, they dissolve. The DNA in your nucleus unspools. The water in your blood separates into hydrogen and oxygen. You wouldn't even have time to feel it, as the neurons in your brain would lose the ability to send electrical signals. You would simply transition from a complex biological being into a cloud of stray atoms in a fraction of a second. Then, we reach the atomic level. Within 10 to the power of minus 19 seconds of the end, we encounter the strong nuclear force. This is the most powerful force in the universe. It is what holds quarks together to form protons and neutrons, and what holds those protons and neutrons together in the nucleus of an atom. For 14 billion years, this force has been the ultimate anchor of matter, but even the strong force has a limit. As the expansion rate approaches infinity, the space inside the proton itself begins to grow. The quarks are pulled apart. At this point, the very concept of matter is dead. There are no more atoms. There are no more particles. There is only a sea of disconnected energy, being stretched so thin that the density of the universe drops towards zero. This leads us to the singularity of the rip. In mathematics, a singularity is a place where the numbers go to infinity and the laws of physics break down. In the Big Rip, the scale factor of the universe, the measure of its size, becomes infinite. At the same time, the Hubble parameter, the speed of expansion, also becomes infinite. This happens at a specific finite point in time. It is the literal end of the road. There is no after because time itself is tied to space, and space has been shredded. The universe becomes a state of infinite distance between all points. Even if a particle of light existed, it could never move from one point to another because the gap between those points is growing faster than light can travel. It is a universe of absolute frozen isolation. Why is this theory gaining ground now? It comes back to the Dark Energy Survey and the DESI results from 2024 and 2025. When scientists mapped the distribution of galaxies across the sky, they found that the clumpiness of the universe is slightly different than what the standard models predicted. This sigma-8 tension, combined with the Hubble tension, suggests that dark energy might be thinner in the past and thicker in the present. If dark energy is growing, then we are on the phantom energy track. We are watching a cosmic evolution that leads directly to the rip. The James Webb Space Telescope has added to this mystery by finding monster galaxies in the early universe. These galaxies grew too fast and too large, suggesting that the push and pull of the early cosmos was much more aggressive than we thought. If the push was stronger then, and it's getting stronger now, the Big Rip isn't just a scary story, it's the most likely data-driven conclusion. We also have to discuss the vacuum decay versus the Big Rip. Some people think the universe will end if a bubble of a new vacuum state expands at the speed of light and deletes us. But the Big Rip is more inevitable. Vacuum decay is a random quantum event, a cosmic accident. The Big Rip is a structural failure. It is the result of the equation of state of the universe itself. If the parameter W is less than -1, the rip is built into the blueprint of reality. You can't avoid it with technology, and you can't outrun it. It is the ultimate expression of entropy and chaos winning the war against order and gravity. Consider the dark flow anomaly. Observations of galaxy clusters have shown that they all seem to be drifting toward a specific point in the sky, as if something outside the observable universe is pulling on them. While this is still controversial, it hints that our bubble of the universe is not the whole story. If there is a greater space-time fabric beyond what we can see, and that fabric is also being stretched or torn, the Big Rip might just be one small part of a much larger cosmic collapse. We might be living in a section of the multiverse that has caught a phantom energy infection. Once the expansion starts to accelerate past a certain point, there is no immune system in physics that can stop it. Let's talk about the paradox of the observer. If the Big Rip is coming, what does that mean for the information in the universe? In physics, there is a law called unitarity, which says that information can never be truly destroyed. But in a Big Rip, every bit of information, every photon, every wave, every particle, is separated by an infinite distance. They can never interact again. They can never form a new star or a new brain. This is information death. It is a fate worse than the heat death, where energy is just spread out thinly. In the Big Rip, the very links between pieces of information are severed. The universe doesn't just forget, it deletes the ability to remember. Could string theory or loop quantum gravity save us? These theories try to combine gravity with quantum mechanics. In some versions of string theory, there is a minimum length called the Planck length. These theorists argue that you can't rip space because space is made of tiny, unbreakable loops or strings. If this is true, the Big Rip might reach a maximum stretch and then stop, or perhaps bounce back. This would lead to a big bounce or a cyclic universe, but this is purely speculative. All of our current measurable data, the stuff we can see with our telescopes, points away from a bounce and toward a total final rupture. The phantom doesn't care about our theories, it only cares about the expansion rate. We must also compare this to the Big Freeze. For a long time, the Big Freeze was the most popular theory. In that version of the end, the universe just keeps expanding at a constant rate. Stars burn out, black holes evaporate through Hawking radiation, and the universe becomes a cold, dark, empty place. It's a slow, lonely death that takes trillions upon trillions of years. But the Big Rip is different. The Big Rip is a violent death. It has a deadline. It happens on a schedule. It transforms the universe from a long-term retirement home into an execution chamber. If the Hubble tension is a sign of phantom energy, then the Big Freeze is a fantasy, and we are living in a universe that has a much more explosive temper. The role of virtual particles in this end is also fascinating. In quantum field theory, the vacuum is filled with particles that pop in and out of existence. These particles are usually tied to each other and disappear instantly. Но в сценарии Великого Разрыва пространство расширяется так быстро, что эти пары частиц могут быть разделены до того, как они аннигилируют. This would mean that the rip would literally create matter out of the vacuum at an infinite rate right before the end. The sky would be filled with a blinding, hellish radiation as the vacuum itself bleeds particles into existence. It would be a final, brilliant flash of light before the total darkness of the singularity. We are now at a point in human history where we can finally see the end. For the first time, we aren't just guessing based on myths or philosophy. We have the dark energy spectroscopic instrument mapping millions of galaxies. We have the Euclid mission looking for the fingerprints of phantom energy in the shapes of the cosmos. We have the Nancy Grace Roman Space Telescope coming soon, which will measure the expansion history of the universe with a precision we've never had before. Every one of these tools is a lens pointed at our own funeral. We are looking for the W value. We are looking for the number that will tell us if our atoms have an expiration date. The cosmic horizon is another key concept. Because the universe is expanding, there is a limit to how far we can see. Light from galaxies beyond a certain point will never reach us because the space between us is growing too fast. In a big rip, this horizon starts to shrink. Today, our horizon is about 46 billion light-years away, but as the phantom energy takes over, the horizon pulls in closer and closer. Eventually, the horizon is only a few million light-years away, then a few thousand, then a few meters. When the horizon is smaller than your own body, you can no longer see your own feet. You are effectively in a universe of one. The Big Rip is the ultimate process of deglobalization for the cosmos. It breaks the universe down into the smallest possible pieces and then isolates those pieces forever. What if the dark matter we've been looking for is actually part of the problem? Some theories suggest that dark matter can decay into dark energy. If this is happening, then the glue of the universe is literally turning into the explosive. As galaxies lose their dark matter, they become easier for the dark energy to tear apart. It's a double-edged sword. The very thing that allowed galaxies to form in the first place might be the fuel for their eventual destruction. We are watching a slow-motion transformation of the universe's infrastructure. The bones of the cosmos are melting into a gas that pushes everything away. The large-scale structure of the universe, the cosmic web, is the most beautiful thing we have ever discovered. It is a network of filaments and voids that looks like a cathedral of light. But the Big Rip is the unweaving of this web. We are currently in the era where the web is at its most complex, but in the future, the filaments will snap, the voids will grow and consume the light. The cathedral is being demolished one brick at a time by an invisible force that lives in the gaps between the bricks. This is the cosmic fatalism we must face. We are the inhabitants of a building that was never meant to last. As we continue to process the data from the James Webb and Euclid, we must remain open to the possibility that our understanding of time is also incomplete. If the Big Rip is the end of space, it must be the end of time as we know it. Some physicists think that time is an emergent property, something that only exists because matter and energy are interacting. If you remove the interactions by separating every particle with an infinite distance, does time still flow? Or does the universe enter a state of eternal now, where nothing can ever happen again? The Big Rip might be the moment where the clock of the universe finally runs out of gears to turn. The phantom fury is not just a mathematical curiosity, it is a shadow that hangs over every star and every galaxy. It is the reason why the Hubble tension is the most important problem in science today. If we can solve that tension, we can solve the mystery of our fate. We are like detectives looking at a crime scene before the crime has even happened. We see the motive, dark energy, we see the weapon, phantom energy, and we see the victim, the entire universe. All that's left is to determine the time of death. As we move deeper into this cosmic autopsy, we have to confront the most lonely aspect of the Big Rip, the shrinking of the cosmic horizon. In our current era, the light from distant galaxies can still reach us, even if those galaxies are moving away. But as the phantom energy density surges, the Hubble radius, the distance at which objects move away from us at the speed of light, begins to contract. Today, that radius is billions of light-years wide, but in the final stages of the rip, that sphere of visibility begins to collapse inward like a closing eye. Eventually, the horizon becomes smaller than the distance between galaxies. Then it becomes smaller than the distance between stars. Imagine being an astronaut in a future where the horizon has shrunk to just a few light-years. You would look out of your window and see nothing, not a single star, not a single nebula, not a single point of light. The universe would have effectively become a series of one-person universes, where every inhabitant is trapped in a bubble of space so small that no signal from the outside can ever penetrate it. This is the ultimate darkness, a total disconnection from the rest of reality. We must compare this violent end to the more traditional Big Freeze to truly understand the horror. In the Big Freeze, the universe expands forever, but the expansion is polite. It doesn't tear atoms apart, it just separates galaxies. Over trillions of years, stars run out of fuel and the lights go out one by one. The universe becomes a graveyard of black holes and cold iron spheres. It is a slow, quiet, and peaceful decay. But the Big Rip is a revolt. It is a universe that has lost its patience. Instead of a slow fade into sleep, the Big Rip is a screaming, frantic disintegration. While the Big Freeze gives life a chance to survive for trillions of years around the glowing embers of white dwarfs, the Big Rip sets a hard deadline. It tells us that time itself is a limited resource, and that the very room we are standing in is about to be demolished by the foundation it was built on. This brings us to the quantum vacuum and the possibility that we are living in a false vacuum. Some physicists argue that the energy of space isn't just dark energy, it's a field that hasn't reached its lowest possible state. If a bubble of a lower energy state were to form somewhere in the cosmos, it would expand at the speed of light, rewriting the laws of physics as it goes. But the phantom energy of the Big Rip is even more insidious. It doesn't need a bubble or a random event. It is a fundamental property of the way space-time evolves. If the parameter W is less than -1, the rip is not an accident, it is the default setting. We are currently watching the James Webb Space Telescope find galaxies that are far more massive and mature than they should be at that early age. This is the impossible galaxy problem. If gravity was more effective at pulling matter together in the early universe, it might mean that the dark energy was also behaving differently back then. If the strength of these forces is shifting over billions of years, we have no reason to believe they will stay stable for us. Let's look closer at the phases of the disintegration. When we talk about the militant expansion of the vacuum, we are talking about a pressure that acts on the very glue of the cosmos. The strong nuclear force that holds your protons together has a specific range. It only works over a distance of 10 to the power of -15 meters. As the Big Rip approaches its climax, the space inside that tiny distance begins to expand so fast that the gluons, the particles that carry the force, can no longer bridge the gap. It is like trying to hold hands with someone while you are both being pulled apart by a jet engine. At some point, the connection just snaps. When the strong force fails, the protons and neutrons themselves dissolve into a quark-gluon plasma, but even that plasma is instantly diluted by the infinite expansion of the vacuum. There is no heat generated by this process, no fire, no bang. It is a cold mechanical separation of everything that exists. The Hubble tension is our only warning sign. Scientists are currently divided into two camps. One camp believes our measurements are just slightly off, and the universe is stable. The other camp, the crisis in cosmology camp, believes that the discrepancy between the early universe and the late universe is proof of new physics. If this new physics includes dynamic dark energy, then the Big Rip is the inevitable winner of the cosmic lottery. We are looking at data from the Dark Energy Spectroscopic Instrument, which suggests that the density of dark energy might have fluctuated over the last 10 billion years. If it can fluctuate, it can evolve, and if it evolves toward the phantom state, we are already on the downhill slope. The Euclid telescope, launched recently, is currently measuring the shapes of billions of galaxies to see if the expansion pressure is changing. Every byte of data sent back from Euclid is a piece of the puzzle that determines if the universe will eventually tear us to pieces. Consider the information paradox in a ripping universe. In our current understanding of physics, information, the data that describes a particle's state, cannot be destroyed. Even if you fall into a black hole, your information is thought to be preserved on the surface. But in a Big Rip, the causal links between every point in space are severed. If two particles are separated by the rip, they can never, ever communicate again. They are essentially deleted from each other's reality. This creates a total information loss. It is as if the book of the universe isn't just being burned. Every letter is being moved to a different, infinitely distant library. There is no way to reconstruct the story. The Big Rip is the ultimate eraser. It leaves the universe in a state of maximum entropy, but with a twist. The entropy is spread across an infinite volume, meaning the density of information becomes exactly zero. We also have to ask what this means for time. According to Einstein, space and time are one thing: space-time. If you rip the space, do you rip the time? Many theorists believe that time only flows because there is change. Change requires particles to move, to interact, to exchange energy. In the final stage of the Big Rip, where every particle is isolated by an infinite distance, change becomes impossible. No two things can ever meet. No two waves can ever interfere. The universe enters a state of frozen nothingness. Time might technically exist, but it would have no arrow. There would be no difference between the past and the future, because the state of the universe would be identical at every moment, a perfect, empty, infinite void. This is the end of history in the most literal sense possible. Why does the American audience and the scientific community find this so compelling? Because it challenges our cosmic optimism. We like to think that the universe is a place where life can eventually master the laws of physics and live forever. We talk about Type 3 civilizations that can harness the power of entire galaxies. But the Big Rip is the great leveler. It doesn't care about your technology. It doesn't care how many stars you have colonized. It attacks the stage you are standing on. You cannot build a shield against the expansion of the space inside your own atoms. It is a natural disaster on a scale that makes a supernova look like a candle flame. It is the ultimate humbling of the human ego. We are guests in a house that is currently being demolished around us, and we only just noticed the cracks in the ceiling. Some researchers are looking for exit ramps. One theory is loop quantum gravity, which suggests that space is not a smooth fabric, but is made of atoms of geometry. These atoms can only be stretched so far before they resist. If this is true, the Big Rip might reach a point of maximum tension and then snap back. This would lead to a big crunch or a big bounce. In this version of the story, the rip is just the inhale before a new exhale. But this is hope disguised as science. So far we have zero evidence for a minimum size of space that could stop the rip. All we see is a universe that is stepping on the gas and shows no sign of hitting the brakes. The dark energy seems to have an infinite supply of push. As we look at the latest deep field images from the James Webb, we see galaxies that look like tiny fragile jewels. We see the cosmic web as a glowing network of life and energy. It is hard to imagine that all of this is temporary, but the cosmic fatalism of modern physics tells us that the beauty of the universe is a coincidence of timing. We are living during the golden age of astronomy precisely because the universe hasn't started ripping yet. If we had evolved 10 billion years from now, we would see a sky with no stars. If we had evolved 20 billion years from now, our atoms wouldn't be able to form. We are the lucky generation, the observers who got to see the masterpiece before the canvas was shredded. The Hubble constant is 73.3 kilometers per second per megaparsec. That number is the heartbeat of the expansion. Every time a new study confirms this number, the tension with the early universe measurements gets tighter. This tension is the shadow of the Big Rip. It is the ghost in our equations. We are trying to build a theory of everything, but the everything we are trying to describe is fundamentally unstable. We are like architects trying to design a skyscraper on a foundation of exploding air. The more we learn about dark energy, the more we realize that it is the main character of the cosmic story, and we are just extras in a scene that is about to be cut. We must also consider the Boltzmann brain paradox in the context of the rip. In a universe that lasts forever, like the Big Freeze, random fluctuations in the vacuum could eventually create a conscious brain out of thin air. This brain would exist for a second, perceive the universe, and then die. But in a Big Rip universe, there isn't enough time for this to happen. The rip cleans the vacuum before these random ghosts can appear. In a strange way, the Big Rip is a cleaner end. It prevents the universe from becoming a place of infinite delusions. It provides a final resolution. It is a full stop at the end of the sentence of existence. Think about the distance one last time. Today you can drive to the store, you can fly to another country, and we can send probes to Mars. All of these things are possible because space is lazy. It stays mostly where it is, but the phantom energy is active. It is ambitious. It wants to turn every millimeter into a kilometer. It wants to turn every meter into a light year. When you realize that distance is a variable and not a constant, the world becomes a very scary place. The Big Rip is the realization that stability is an illusion. We are floating on a bubble that is being blown larger and larger by a phantom mouth, and every bubble, no matter how large, eventually pops. The DESI results from 2024 and 2025 have given us the most detailed map of the growth of the universe ever made. What that map shows is a growth spurt. The universe is growing up too fast. In biology, when a cell grows too fast and ignores the signals to stop, we call it cancer. Dark energy might be the cosmic cancer. It is an unregulated growth that eventually kills the organism. The organism in this case is the universe itself, and we are the bacteria living on a single cell, wondering why the environment is suddenly getting so stretched out. To understand the true nature of this phantom energy, we have to look at the very foundation of how we measure reality. In physics, we use a value called the equation of state, represented by the letter W. For normal matter, like the atoms in your body or the stars in the sky, this value is 0. For radiation, like the light from the sun, it is 1/3. but for dark energy, the value is negative. If W is exactly -1, then the density of dark energy remains constant as the universe expands. This is the cosmological constant that Albert Einstein once feared. In this scenario, the universe expands forever, but it stays together. However, if the value of W is even slightly less than -1, say -1.1 or -1.05, we enter the territory of the phantom. This tiny numerical difference is the difference between a universe that lasts for trillions of years and a universe that explodes in a few billion. It is a mathematical tipping point that turns the vacuum from a passive background into an active, aggressive predator. The latest data from the dark energy spectroscopic instrument suggests that we might be living in exactly that kind of evolving universe, where the value of W is not a fixed number, but a moving target that is drifting deeper into the negative. If the Big Rip is the violent end, we must compare it to the peaceful end, known as the Big Freeze, or the heat death. In the Big Freeze, the expansion of the universe is like a slow, cooling embers of a fire. Galaxies move away from each other, but the internal structure of the galaxies remains intact. Stars eventually run out of hydrogen, turn into white dwarfs, and then fade into black dwarfs. Black holes slowly evaporate over timescales so long that the human mind cannot even begin to comprehend them, numbers like 10 to the power of 100 years. It is a slow, lonely, but fundamentally stable death. The Big Rip, however, is the complete opposite. It is a structural failure of the vacuum. While the Big Freeze allows for the possibility of advanced civilizations surviving for billions of years around the fading heat of dead stars, the Big Rip sets a hard expiration date on every molecule. It is the difference between a house slowly falling into ruin over centuries and a house being blown apart by dynamite. The cosmic fatalism of the Big Rip is the realization that we are not just fading away, we are being executed by the very space we occupy. This brings us to the quantum pressure of the vacuum. According to quantum field theory, empty space is never truly empty. It is a roiling, bubbling sea of virtual particles and fields. One of these fields is the Higgs field, which gives particles their mass. Scientists have long wondered if the Higgs field is in its true ground state, or if it is stuck in a false state. If the vacuum is false, it could suddenly transition to a lower energy state, sending a bubble of destruction through the universe at the speed of light. But the Big Rip is a different kind of vacuum instability. It is a global instability. Instead of a single bubble, the entire fabric of space-time begins to boil with phantom energy. As the density of this energy increases, it begins to interfere with the virtual particles that pop in and out of existence. Normally, these particles appear and then instantly annihilate each other. But in the final moments of the Big Rip, the space between these particles grows so fast that they can never meet again. The vacuum literally begins to produce real matter and radiation out of nothing, filling the dying universe with a hellish, ghostly glow right before the final rupture. We must also consider the Hubble tension as the ultimate warning siren. For decades, we thought we knew the speed of the expansion, but the more we look, the more the numbers refuse to agree. The Planck satellite looking at the early universe gives us a slower speed. The James Webb and Hubble telescopes looking at the modern universe give us a faster speed. This discrepancy is not a mistake, it is a signal. It suggests that the dark energy has changed its behavior over the last 13 billion years. It is as if the universe has hit a second stage of its rocket engine. If the acceleration continues to increase, it confirms that dark energy is not a constant lambda, but a dynamic quintessence, or phantom field. This is why the Euclid mission and the Nancy Grace Roman telescope are so critical. They are designed to measure the history of the expansion. If they find that the push was weaker in the past and is stronger now, the Big Rip moves from a maybe to a certainty. We are looking for the acceleration of the acceleration. The philosophical impact of the Big Rip is profound. It forces us to reconsider the permanence of information. In a standard universe, even if life goes extinct, the record of our existence, the light from our sun, the radio waves we sent into space, continues to travel forever. But in a Big Rip, even light is eventually trapped. As the cosmic horizon shrinks, every bit of information we have ever created is isolated into a tiny, shrinking bubble. Eventually, the space between the start of a radio wave and the end of that same wave grows faster than the wave itself can travel. The signal is literally stretched into non-existence. This is total erasure. It is a universe that leaves no ghost, no memory, and no trace. It is the ultimate expression of entropy, where not only is energy spread out, but the very possibility of connection is destroyed. We are living in a brief moment of cosmic coherence, where things can still touch each other across the void. That coherence is a fragile gift, and the phantom energy is the force that will eventually take it back. Let's talk about the gravity of the void. We usually think of gravity as something that pulls things together, but in general relativity, gravity is the curvature of space-time. Dark energy is essentially negative gravity. It curves space in the opposite direction. In a Big Rip scenario, this negative curvature becomes so extreme that it creates a cosmological singularity. Usually we think of singularities as being in the center of black holes or at the beginning of the Big Bang. But the Big Rip is a future singularity. It is a point in time where the curvature of the universe becomes infinite. At this point, the Einstein field equations themselves break down. We simply do not have the math to describe what happens when the distance between 2 points becomes more than infinite. It is the edge of the map of reality. Some theorists think this might be a phase transition, where space-time evaporates into something else, perhaps a pre-geometric state where space and time do not exist at all. Why does the James Webb Space Telescope keep finding impossible galaxies? Galaxies that are too big, too bright, and too early. One radical explanation is that the dark energy in the early universe was actually stronger than we thought, but it was behaving differently. If dark energy can change its flavor over time, then our current period of stability is just a temporary phase. We might be moving toward a phase 3 of the universe, where the phantom energy becomes the dominant force. The DESI results from 2024 and 2025 have shown that the clumpiness of the universe is not what we expected. Galaxies are not clustering the way the standard model says they should. This suggests that there is a hidden hand pushing the matter around. That hand is the phantom. It is the invisible architect that is currently preparing to tear down the building it helped create. Consider the scale of the rupture one last time. We are talking about a force that starts at the level of billions of light years and ends at the level of a billionth of a meter. It is a top-down destruction. In the final seconds, the phantom energy density reaches the Planck density. This is the point where the energy of the vacuum is so high that quantum gravitational effects become the most important thing in the universe. At this scale, space-time might not be a smooth fabric anymore. It might be a quantum foam of interconnected loops and holes. The Big Rip would be the process of popping those quantum bubbles. It is the final dissolution of the geometry of existence. Without geometry, there is no where. Without where, there is no us. The Great Rip is the ultimate dark mirror to the Big Bang. The Big Bang was a moment where space and time were born from a single point and expanded outward. The Big Rip is the moment where space and time expand so much that they return to a state of nothingness. It is a symmetric ending to a symmetric beginning. But while the Big Bang was a moment of creation and inflation, the Big Rip is a moment of disintegration and exhaustion. We are the children of the inflation, living in the expansion, and destined for the rupture. Every observation we make with our billion-dollar telescopes, from the Perseus cluster to the pillars of creation, is a data point in the story of this coming storm. We are watching the universe prepare for its final act. The Hubble constant is the timer. The phantom energy is the fuel. And the Big Rip is the curtain call for the entire show. As we look out at the night sky tonight, we see a universe that looks solid and eternal. But that is an illusion created by our tiny human lifespan. On a cosmic scale, the stars are just sparks in a darkening room. The cosmic web is a cobweb that is about to be swept away. The Big Rip is the most honest end the universe could have. It doesn't pretend that things will go on forever in a slow, boring decay. It doesn't offer the false hope of a big crunch where we are recycled. It is a violent, absolute, and final statement. It is the universe saying that the void is the only thing that is truly eternal. Everything else, the stars, the planets, the atoms, and the people, is just a temporary ripple in a sea of phantom energy that is about to turn into a tidal wave.